Is the sun about to flip? No, this isn't science fiction. It's a real, measurable event happening within the solar cycle, and, well, understanding it matters far more than most people realize. The sun's magnetic poles are preparing for a full reversal, something that happens roughly once every 11 years. For researchers, this is one of the most important events in heliophysics. For anyone living on Earth, it's a reminder that our star is not a static ball of fire, but a dynamic engine whose internal changes ripple across the entire solar system. What follows is a grounded breakdown of what a solar pole flip actually is, why it happens, what it means for Earth, and why the popular fears around darkness, shutdown, or cosmic catastrophe tell the wrong story. To understand what's unfolding right now, start with the nature of the solar cycle. Every 11 years, the sun transitions from a minimal phase to a maximal one. During the minimal phase, solar activity is relatively calm, with fewer sunspots and lower electromagnetic disturbances. But as the cycle approaches its maximum, the sun becomes far more active. Sunspots erupt, solar flares spike, and coronal mass ejections, vast expulsions of plasma and magnetic fields, become more frequent. This rhythm is ancient and predictable, and the magnetic pole reversal is the climax of the cycle. The poles don't rotate or flip physically like a planet's axis. Instead, the sun's magnetic field becomes increasingly tangled by the solar dynamo, the churning, electrically charged plasma inside the star. Eventually, the field becomes so distorted that it collapses and regenerates in the opposite orientation. The moment of reversal signals the peak of solar activity. Historically, this is the period where Earth experiences the most dramatic space weather effects. That's where the real implications begin, because Earth is deeply connected to the Sun through the magnetosphere, our protective magnetic bubble. When the Sun enters this chaotic state, the solar wind becomes stronger and more variable, interacting with Earth's magnetic field in unpredictable ways. This interaction can compress the magnetosphere, shift it, or inject high-energy particles into it. None of this plunges Earth into darkness, but it does expose the technologies we depend on to additional stress. Let's look at the practical, historically documented consequences. Strong solar storms have disrupted navigation systems, affected power grids, interfered with radio communications, and forced airlines to reroute polar flights. The 1989 geomagnetic storm in Quebec shut down the entire provincial power grid in under 2 minutes. The famous Carrington event of 1859 set telegraph wires on fire and produced auroras visible near the equator. A similar storm today would be far more disruptive simply because, well, modern society relies on electronics at every level. During a magnetic reversal, the likelihood of storms powerful enough to produce these effects increases, not because the sun becomes lethal, but because it becomes far more electromagnetically active. The real question is whether this upcoming reversal carries risks dramatically different from previous cycles. Based on current scientific understanding, the answer is no. This reversal is part of an ordinary solar maximum. The sun has flipped its poles countless times during the lifespan of our species. The effects depend not on the reversal itself, but on the strength of the solar storms that accompany it. Some cycles produce mild disturbances, others produce historical outliers. The cycle we are currently entering appears to be stronger than predicted, but still within normal historical boundaries. What matters most is our global dependence on satellite constellations, power grids, and high-frequency communications. You know, the Sun doesn't actually need a catastrophic superstorm to affect our modern infrastructure. Even moderate geomagnetic storms can knock satellites offline or, well, disrupt GPS accuracy. If we try to understand this period through a historian's lens, it helps to compare the present to past solar maxima. Back in the early 20th century, storms affected radio networks. Then, in the 1960s, they interfered with early satellites, and by the 2000s, they were disrupting aviation routes and GPS. The pattern here is pretty clear. Society has become more vulnerable, not because the Sun itself is changing, but because our systems have, become more sensitive. So, the most important preparation for this pole reversal isn't really about fearing some cosmic collapse. It's about being aware of just how interconnected our technology is, and considering what steps should follow from that. Governments and energy operators, well, they track solar weather constantly. Power companies adjust grid loads during major solar events. Satellite operators will harden their systems or place them in safe mode when solar radiation spikes. Airlines, too, reroute away from the poles when radiation increases. These are practical, established procedures, definitely not emergency measures. You know, the notion that Earth could be plunged into darkness really stems from the misunderstanding that a solar pole reversal works like a planetary pole flip. Earth's magnetic poles have shifted many times, but Earth does not tip over or black out, and, well, the Sun certainly does not either. The Sun's reversal affects magnetic geometry, not its ability to produce light. If anything, the Sun becomes just a bit more luminous during maximum activity, nowhere near enough to affect climate directly, but, certainly enough for researchers to measure. What's really worth watching in the coming period is the quality of the storms, not the reversal itself. If the Sun launches a large coronal mass ejection in Earth's direction, it can cause geomagnetic disturbances. If a storm of rare strength were to occur, it could damage transformers, disrupt satellites, and, well, even cause power outages. These scenarios are part of the general risks of living near a star, not the product of the pole flip. Understanding the difference allows you to interpret sensational headlines with clarity rather than panic. The Sun's pole reversal is not a threat to life. It's actually a reminder that Earth exists within a dynamic cosmic environment shaped by forces far larger and older than anything on our planet. It's also a moment when global technology must be monitored more closely. The Sun's behavior is not a mystery. It is a cycle, a pulse, a natural system with measurable patterns. And as we watch this reversal unfold, we learn more about our own vulnerability, not to darkness, but to the infrastructure we've built around electricity and communication. If you want more grounded, data-driven breakdowns of cosmic events and the hidden systems that connect them to life on Earth, subscribe to Strange Planet and share this episode with those who want real explanations instead of exaggerated myths.